Welcome to another Java tutorial. Today, we'll dive into a powerful debugging tool that can help you catch exceptions in your Java applications more effectively: exception breakpoints. Whether you are a seasoned developer or just starting, mastering breakpoints can significantly improve your debugging process. To start, let's talk about what an exception breakpoint is. An exception breakpoint allows you to pause execution when an exception is thrown, giving you the chance to analyze the context in which the exception occurs. This can be invaluable in identifying bugs in your code. Before we jump into coding, let's make sure we have our environment set up. We will use an IDE that supports Java debugging, like IntelliJ IDEA or Eclipse. Do you have your IDE ready? Great. Let's get to it. First, let's create a simple Java project to demonstrate exception breakpoints. I will create a new Java class called main. Here's how the class looks initially. Now, let's add some code that is likely to throw an exception. In this case, we'll create a method that divides two numbers. If the divisor is 0, it will throw an arithmetic exception. Let's implement this method. As you can see in this example, we are calling the divide method with a divisor of 0, which will indeed throw an arithmetic exception. Next, let's set an exception breakpoint in our IDE to catch this exception. In IntelliJ IDEA, you can set an exception breakpoint by clicking on the Run menu and selecting View Breakpoints. Or you can simply press Ctrl plus Shift plus F8. Once there, click on the plus icon and select Java Exception Breakpoint. Now, in the Add Exception Breakpoint dialog, you'll want to search for Arithmetic Exception. This is the exception that we expect to be thrown when we run our code. After selecting it, make sure the caught and uncaught options are checked so that it breaks for both cases. Let's take a moment to discuss what the caught and uncaught options mean. A caught exception is one that is handled by your code, meaning you have a try-catch block around it. Conversely, an uncaught exception is one that propagates up the call stack without being handled by your code. With the exception breakpoint set for arithmetic exception, it's time to run our application in debug mode. Click on the debug button, which should look like a small bug icon in your IDE. This will start the execution of your application. Once we hit the division by 0, the program execution will pause at the exception breakpoint. Now we're in debug mode. You should see a stack trace and the context in which the exception occurred. Let's take a look at what's on the screen. In the Variables panel, you can inspect local variables. You'll notice that the variable b is 0. This is the reason for our exception. With this information, you can now modify your code to handle the division by 0 scenario appropriately. Let's go ahead and modify our divide method to handle exceptions gracefully. We'll implement a try-catch block so that we can manage the arithmetic exception. Now that we have set up our error handling, let's run our program again in debug mode. We expect to see our message in the console, and the application should now safely return 0 instead of crashing. When you rerun the application, it will not break at the exception thanks to our try-catch block. However, you can still debug and analyze what happens when an exception is thrown without terminating your program immediately. This is an essential aspect of error handling. Next, let's set an exception breakpoint for null pointer exception. This is another common exception in Java applications. Instead of modifying our previous example, let's create a new method that intentionally causes a null pointer exception. Add this method to the main class and call it from the main method. This will result in a null pointer exception when we try to access the length of a null string. Now, repeat the process of setting an exception breakpoint for null pointer exception, just like we did with arithmetic exception. Remember to check both the caught and uncaught options. Run your application again in debug mode. This time, when the null pointer exception is thrown, your IDE will stop execution at the exception breakpoint. Similar to before, you can analyze the state of your application at the point the exception occurs. Let's take a moment to sum up what we have learned so far. Exception breakpoints allow you to pause program execution at the point an exception is thrown. This feature is incredibly useful for comprehensively understanding crashes and error handling in your application. Remember that you can set breakpoints for other exceptions too, such as IO exception, class not found exception, and so forth. The process is the same as we've shown, so don't hesitate to explore and add exception breakpoints as per your debugging needs. Now, let's address a more advanced use case. Imagine you want to set breakpoints only under certain conditions. Both IntelliJ IDEA and Eclipse allow you to set conditional breakpoints. For example, you may want to break when a variable reaches a specific value. Let's do this with our divide method. In IntelliJ IDEA, after adding a new breakpoint by clicking next to the line number, right-click the breakpoint and select More. Here you can enter a condition like b == 0. This way, the breakpoint will only trigger when b is actually 0. Similarly, in Eclipse, you can achieve this by right-clicking on the breakpoint, selecting Breakpoint Properties, and checking the option for a conditional breakpoint. This level of control can make a huge difference in debugging, especially when dealing with large codebases or complex logic. Now that you have a strong grasp of exception breakpoints and how to use them effectively in your Java applications, I've compiled a couple of best practices to keep in mind. First, don't set breakpoints on every exception. Focus on exceptions that you expect to cause runtime issues or where you know your handling may fail. Second, use conditional breakpoints to avoid breaking on exceptions that are part of your normal application flow. This will keep your debugging sessions productive and focused. Lastly, remember to remove or disable unnecessary breakpoints when you're done debugging. Too many active breakpoints can clutter your debugging workflow. Now, as we wrap up our tutorial, I hope you found this guide on exception breakpoints informative and useful. Remember, debugging is a vital skill for any developer, and mastering exception handling will go a long way in improving your code quality. If you enjoyed this video, please give it a thumbs up and subscribe to the channel for more Java tutorials just like this one. Don't forget to share your thoughts or questions in the comments below. Until next time, happy coding!